Another question, implement stack using queues. And this is our problem number 225 on LeetCode, marked easy. Here in this problem we want to implement the stacks using queues. So here we will take 2 queues and 1 stack, and our stack follows LIFO and queues follows FIFO. Okay, here we have to implement the myStack class, and these 4 functions we have to implement. Let me see if this is the example for understanding purpose. And there is some note. What it is saying, you must use only standard operation of a queue, which means push to back, peek, or this kind of. Depending on your language, the queue may not be supported natively. And a queue using a list or DQ, as long as you can use only a. Okay, so leave this line. So our constraint is, our new element is from 1 to 9. We can push minimum 1 to 9 element. This is the constraint given to us. Maximum 9 new element we can take. At most 100 calls will be made to this 4 operation. Okay. So now I move on to the code explanation part. So here we took 2 queues, Q1 and Q2. Here we are using the stack using queue. So instead of taking 1 queue, we took 2 queues, Q1 and Q2. One thing to be noted is that the element at the top of stack will be same as the element at the front of this queue Q1. So we will do 3 steps to solve this problem. First one, we will push all the elements from the Q1 to Q2. Okay, then after pushing all the elements from the Q1 to Q2, our Q1 becomes empty. We will push the new element X, this X, which is 3. If we take the example of 1 to 3, we push the new element 3 into Q1. Then after that we will copy all the elements from the Q2 to Q1. Our elements are in order of Q2 as 2 1. So now, and after pushing the new element in Q1, so our Q1 is having element 3 and Q2 is having 2 1. So after copying element from Q2 to Q1, our element of Q1 becomes 3 to 1, which is the desired answer. And if we push 1, 2, 3 in stack, so our elements order in stack is like 1 is the most bottom, and then 2, and then 3. 3 is top of stack, which is the front of our Q1. Then by doing this, our order of element inside Q1 is same as the order of the element placed in the stack. This top function is easy. Here we need to return the top of stack, which is front of Q1, which is Q1 dot front. Okay, so here bool empty, here we need to return our stack is empty stack. So whenever stack is empty, our q1 is also empty, because here our q1 queue is playing the role of our stack here, and q2 is our helper queue. As we are taking the help from the q2, main function is push and pop. Let me walk you through the push function. Implementing our push function. Inside this push, we have passed the element x, and now among this push and pop function, any one function from push and pop function, we can choose any function in which we can run the loop inside. So we have chosen the push function, and we run the loop inside it. So we have executed the pop function in constant time. We did the same step that we have mentioned in the notebook, that while जब तक our q1 node becomes empty, what we will do, we will push into q2 में हमने q1 के फ्रंट से एलिमेंट ले जाके पुश कर दिए q2 में, एंड देन q1 से पॉप कर दिए सारे एलिमेंट्स, एंड देन whenever q1 becomes empty, then we push the new element x inside that q1, which is 3 among the 1 2 3 elements. And now what we will do, we will apply the condition to q2. When our q2 is not empty, means elements are present inside the q2 queue, we will push the elements from the q2 front to q1, means q1 से वो q2 के सारे एलिमेंट हमने q1 में पुश कर दिए. q1 डॉट पुश q2 डॉट फ्रंट एंड q2 डॉट पॉप. q2 से सारे एलिमेंट पॉप कर दिए हमने. We have popped all the elements from the q2. Implement the pop function. What we did was, we have taken the answer, which is q1 dot front. q1 front, which is our top of stack, and we popped the element from q1 so that our element from the front of q1 gets popped, and we returned our answer. And these two last one are simple. That answer is q1 dot front, so that q1 dot front is our new element 3. That was our top of stack. No, I'm not fumbling here.